Hello friends, I Agrawal is Assistant Professor in Civil Engineering Department, Sandipani Technical Campus, Latur. Today's topic is influence line diagram for diagonal member of determinate truss. Now, learning outcomes. After watching this video, student will be able to understand the concept of method of section, and also student will be able to draw ILD for diagonal member of truss. Now take a pause and question arises in the mind, what are a method to calculate the member force. So methods, first one is a method of section and second one is a method of joint. Now this is a numeric. Draw influence line diagram for forces in the diagonal member U0 L1 and U1 L2 if the unit load transfers on bottom chord. Here this is a truss having the span of 16 meter and height is a 3 meter. Support L0 is the hinge support and support L4 is the roller support. Now first we draw the ILD for the member U0 L1, this diagonal member. Here we are using the method of section for finding out the forces in the member. So first we have to apply the unit load on the each joint. So here the section is 1 1. This cuts the U0 U1, U0 L1 and the L0 L1. So here take care that this section should not cut the more than the 3 members. Then you have to apply the unit load on the each joint, that is the L0. Then this unit load apply on this L1. Then again this apply the unit load on the L2 and find the force in the member U0 L1. Again apply this unit load on the L3 and finally apply the load on this L4 and find the force in the member U0 L1. So now apply the unit load left of the section. First we are applying the load on the left hand of the section. So apply the unit load on the L0 and consider the equilibrium of the right hand part. So we are applying the force on left hand side of the section. So consider the right hand side of the part as the equilibrium. So when we apply the unit load on the frame, find the reactions. So these are the reactions. R0 that we know is RL0 is equal to 1 minus x by L and RL4 is equal to the x by L. Now here we are considering here this member is subjected to a compressive force. If the value is the positive, that direction is the correct. Otherwise is a reverse direction. So now apply here the static equilibrium condition. So here this angle is a 53.13 because this member is an inclined member. We have to resolve this member. So here we are applying the sigma Fy condition. That is why resolve this member vertically, and we are considering the right hand part as a equilibrium. So only vertical force is a U0 U1 and another force is a reaction RL4. Only the two vertical forces. So resolve this U0 L1 vertically in this way. This U0 L1 cos 53.13. So here only the two forces are here. For the sigma Fy condition, we are considering the equilibrium of the right hand side of this section. So vertically upward is a positive and vertically downward is the negative. So RL4 is a positive and this downward is minus U0 L1 cos 53.13 is equal to 0. So we got here U0 L1 is equal to RL4 divided by cos 53.13. So here we have to find the value of RL4 for the what? L4 is what? X by L. X is the location of the unit force. Initially location of unit force is L0 means x is equal to the 0. So when the x is equal to 0, what is the value of RL4? That is the x by L. So x is equal to 0 and L is the total span. So RL4 is equal to the 0 because here 0 by 16 is the 0. So when RL4 is equal to 0, automatically this FU0L1 is equal to the 0. But we are considering this as a compressive, but this value is 0, that doesn't affect that is a compression or a tension. Now next is apply the unit load on right of the section, because we have to move this load from L0 to L1, which is the right hand side of the section. So consider here unit load applied at the L1. Now we are considering the equilibrium of the left hand part, means this section left hand part. This left hand side means this RL0 and then this members forces. So here again we are applying here the sigma Fy conditions. So now we are assuming that this, when the load is on the right side and we are considering the equilibrium of the left hand side, we are considering that this is subjected to the tension. If the answer is positive, our sign convention is the correct. So here again the angle is 36.87 and we are applying here the sigma Fy condition. So only the forces which are on the left hand side of the section. So sigma Fy means vertical force. So here the RL0 is only the one vertical force, and this U0L1 which resolve vertically, that is another force. So resolve this force vertically downward. So that force is FU0L1 sine 53.13. Only these two forces are the sigma Fy conditions. So right here upward force as positive, so RL0 is positive, and this resolution of this force is a negative because it is a downward. So minus FU0L1 sine 36.87 is equal to the 0. So FU0L1 is equal to RL0 divided by sine 36.87. Now here unknown is the RL0 and RL0 is a 1 minus x by L. So here we have to put the value of x, means location of the unit load. So here location of unit load is a 4. So RL0 is equal to 1 minus this 4 by 16. Here this formula is 1 minus x by L. X is equal to 4 and L is equal to the 16. So RL0 is equal to 0.75. So put this value into our previous formula. So we got here FU0L1 is equal to 0.75 divided by sine 36.87. So FU0L1 is equal to 1.25, and this value is the positive. So what we have assumed, when this load is on the x is equal to 4, this member is subjected to tensile force. What is here meaning? When the unit load is at the distance x is equal to 4, this U0L1 is subjected to the tensile, and that ordinate is the 1.25. Then next we have to move this load on the next joint, that is on the L2. So again we are applying the load on the right hand side of the section, and we are considering the left hand side for the equilibrium conditions. So load is on the right side, considering the equilibrium of the left hand side of this section. This section 1 only consider the left hand part of this section. So again we are assuming that there is a tension in this member. If this value is a positive, what our consideration is a correct. Now angle again the same, that is 36.87, and we are applying here the sigma Fy condition. So this is one vertical force reaction at L0 and resolution of this U0L1. So again resolution is the same, that is the FU0L1 sine 53.13. Now here equation is RL0 positive because this is upward, and this FU0L1 sine 53.13 is downward, is a minus. Now FU0L1 is equal to RL0 divided by sine 36.87. So here unknown quantity is the RL0, and RL0 is depend upon the x. Now the value of x is changes to the 8 meter. So x is equal to 8. What is the value of RL0? So RL0 is equal to 1 minus 8 by 16. RL0 is equal to 0.5. So put this value into our previous equation. F U0L1, that is equal to 0.5 divided by sine 36.87. F U0L1 is equal to 0.83, and this value is positive. It means what we assume, when the x is equal to the 8, means when the unit load is at the 8 meter, this member is subjected to the tensile force, and the ordinate is the 0.83. Now move this unit load on the next joint, that is the L3. Again the apply unit load on the right of the section. So unit load on the L3, and consider the equilibrium of the left hand side part here, section of left hand side. Now again we are assuming here the tensile force in the member U0L1. Angle is the same, 36.86, and we are applying the same condition, sigma Fy equal to 0. Again we are resolving the same force, that is the F U0L1 sine 53.13, and here the condition of sigma Fy RL0 minus F U0L1 sine 36.87 equal to 0. So F U0L1 is equal to RL0 divided by sine 36.87 as per the previous, the same. Again the RL0 is dependent upon the x. Here now x changes to the 12 meter. So what is the value of RL0? So RL0 is equal to 1 minus 12 by 16. So RL0 is equal to 0.25. So F U0L1 is equal to 0.25 divided by sine 36.87. So we got here the value of F U0L1 is equal to 0.415, and this value is positive in what we assume, when this x is equal to the 12, this member is subject to the tensile, and the ordinate at that point, means at a 12 meter, is a 0.415. Now we are moving this load on the next joint. So again we are considering the right of this section and apply the unit load on the L4, and consider the equilibrium condition of the left hand part of this section. Again here consider this member is subjected to the tensile force, angle 36.86. Again apply the same condition, sigma Fy equal to 0 here. So resolution of this diagonal member is a downward, and that is the F U0L1 sine 53.13. So equation is, this reaction is upward, that is why is positive, and this resolution of this force is a downward, is a minus. So RL0 minus F U0L1 sine 36.87 equal to the 0. So F U0L1 is equal to RL0 divided by sine 36.87. Now again here what x is changes to the here 16 meter. What is the value of RL0? So RL0 is equal to 1 minus 16 by 16, that is equal to 1. So 1 minus 1 is 0. So RL0 is equal to 0. Automatically this RL0 is 0. Automatically this F U0L1 is the 0. But here we are considering this as a tensile. But when the value is 0, that doesn't affect the tensile or the compression. So here we got all the ordinates of this ILD when this load is at L0, then L1, then L2, then L3 and the L4. Now we plot the ILD for this member U0L1. So draw the horizontal line equal to the length of the truss. Then x equal to 0, F U0L1 ordinate is a 0. When the x equal to 0, ordinate is a 0. Now next is the, when x equal to 4, here ordinate is the 1.25. So ordinate is a 1.25. Then when x equal to the 8, this ordinate is a 0.83. So here marking the 0.83. Then x equal to 12, it means when the load is at the L3, ordinate is the 0.415, and finally here x equal to 16, the ordinate at that location is the 0. So 0. Now join this line 0 to 1.5, then 1.5 to the finally 0, and we have drawn this line below the reference line because we are considering that the tension as negative and compression as the negative. So here, when the unit load is L0, L1, L2, L3 and L4, for all the values, this member is subjected to the tensile force. So that is why this line is, this ILD is the below the line. Now, the ILD for the member U1, L2, this U1, L2. Again the same procedure, that is the apply the section, section 2. The section should not be cut more than the 3 members. Here this section cuts the U1, U2, U1, L2 and L1, L2, the 3 members. So again here we have to apply the unit load on this all the joints, that is the on L0, then apply load on this L1, then again apply load on the L2, then again apply the load on the L3, and again apply the unit load on the L4, and find the forces in the member U1, L2. Now apply the unit load on the left of the section because the starting point is the left of the section. So we are applying here the load on this L0 joint, and considering the equilibrium condition for the right hand side part of this section. So we are applying the load on this left hand side and considering the equilibrium condition for the right part. Now when the unit load is applied on beam or frame, the reaction is the RL0 is equal to 1 minus x by L, and this second reaction is the x by the L. Now here we are considering the right part for the equilibrium condition. So we are assuming that here is a compressive force. When the load is placed at L0, this member is subjected to the compression. If this value is positive, the member is subjected to compression at that location. So this angle is 53.13, and here we are applying the sigma Fy condition. So here this member is a horizontal U1, U2 that cut, but that is horizontal, so that will not in the sigma Fy condition. Also L1 and L2 is a horizontal, so that will not affect on this sigma Fy condition. So only this diagonal member which can resolve horizontally and the vertically. So only vertically resolution will affect on this sigma Fy condition. So resolve this vertically diagonal member in the vertically downward direction. F U1 L2 is equal to cos 53.13. So here sigma equation of sigma Fy is equal to only right hand side part. So RL4 minus the F U1 L2 cos 53.13 minus, because this force is a downward. Now we got here F U1 L2 is equal to RL4 divided by cos 53.13. So unknown is RL4, and RL4 is equal to the x by L. So value of x, we have to put the value of x. Now initially the value of x is a 0 because we are putting this unit load at the L0, means x equal to 0. What is the value of RL4? So RL4 is equal to 0. So automatically we got here F U1 L2 is equal to 0. And initially we are considering compression, that is correct, but 0 value doesn't affect the compression or the tension because that is on the reference line. That point is on the reference line. Now move this load on the second joint, same the section here. So again apply unit load on the left of the section because this is the again remain L1. So apply load on the L1. Again consider the right hand part of this section for the equilibrium condition. Again the reaction is the same, that is RL0 is equal to 1 minus x by L, and RL4 is equal to the x by L. Again here we are considering this member is subjected to the compressive force. Now this angle is 53.13, and here again we are applying the sigma Fy conditions, so that this U1 U2 becomes the doesn't affect, and this L1 L2 doesn't affect on this sigma Fy condition. Only the diagonal member will affect on this sigma Fy condition. So one condition, one unknown. So resolution of this force is downward, and F U1 L2 cos 53.13. So on the right hand side, only the two vertical forces, this reaction and this resolution of this diagonal member. So equation is RL4, this minus because of downward, F U1 L2 cos 53.13 equal to 0. F U1 L2 is equal to RL4 divided by cos 53.13. Now here x is changes. Here we want to find the value of RL4. RL4 is equal to x by L. So when x is equal to now the 4, because this L1 is located 4 meter from the 0. What is the value of RL4? RL4 is equal to the 4 by 16. So RL4 is equal to 0.25. So put this value into our equation. So F U1 L2 is equal to 0.25 divided by cos 53.13. We got here F U1 L2 is equal to 0.415. This value is positive, means this we assume when the load is on the L1, this member is subjected to the compression, and ordinate of that ILD is the 0.415. Now move this load on the right of this section, because L2 is on the right side. So apply the unit load on the right of the section. Then consider the equilibrium of the left hand side of the section. So we are considering here the left hand side. So now again we have to assume the force in the member U1 L2. So here we are assuming the tension. Means it what? When the unit load at the L2, this member is subjected to tensile. This is our assumption. If the answer is positive, means our assumption is correct. Now the angle is 36.87. Again here we are applying the sigma Fy conditions. So only the vertical force on the left side of the section. So this reaction and resolution of this diagonal member is P U1 L2 sin 53.13. Only these two forces are the vertical. So equation is RL4 minus F U1 L2 sin 36.87. This minus because this resolution is a downward. We are considering here upward positive and the downward negative. So F U1 L2 is equal to RL0 divided by sin 36.87. Now here the x is equal to the 8 here. So what is the value of RL4? No, not RL0, because left hand side. RL0 is equal to 1 minus 8 by 16. RL0 is equal to 1 minus x by L. So RL0 is equal to 0.50. So put this value into our equation. So F U1 L2 is equal to 0.50 divided by sin 36.87. So F U1 L2 is equal to 0.83, and this value is positive, means what we assume in U1 L2 is a tension, that is correct. It means when the unit load is at the L2, this member is subjected to the tensile force, and the ordinate of that ILD is the 0.83. Now move this load on the L3. Apply the unit load on the L3 and consider the left hand side of this section as a equilibrium conditions. Again we are assuming that this member is subjected to the tensile force, and again we are considering the sigma Fy condition here. So resolve this force diagonal member vertically downward F U1 L2 sin 53.13, because we are considering the sigma Fy condition. That is why this U1 U2 and L1 L2 is not effect, or that value is the 0. So equation is RL0 minus F U1 L2 sin 36.87 equal to 0. F U1 L2 is equal to RL0 divided by sin 36.87. Now here is the location of L3 is the x is equal to the 12. 4 plus 4 plus 4. 12. What is the value of the RL0? That is equal to 1 minus this x equal to 12 divided by the 16. So RL0 is equal to 0.25. So F U1 L2 is equal to 0.25 divided by sin 36.87. So we got here F U1 L2 is equal to 0.415. Again, this value is a positive, means what we assume, when the load is on the L3, this member is subjected to the tensile and that ordinate is the 0.415. Now finally, apply the load again on the right side and on the L4 and consider the equilibrium of the left hand side part again. Again we are considering the tensile force and again we are applying the sigma Fy condition same as the previous. A resolution of this force is F U1 L2 sin 53.13. So equation is the same as the previous, RL0 minus F U1 L2 sin 36.87. So we got here F U1 L2 is equal to RL0 divided by sin 36.87. What here? X is equal to now the 16. 4 plus 4 plus 4 and plus 4. What is the value of the RL0? So RL0 is equal to 1 minus 16 by 16. It means the 1. So 1 minus 1 is a 0. So RL0 is equal to 0. So we got here F U1 L2 is equal to 0. We are assuming the tension, that is correct, but value is 0. So that is why this value is on the reference line. So it doesn't affect the tension or a compression. So now we will plot the ILD for the member U1 L2. So draw the horizontal line equal to the length of that truss. And now here, when the x equal to 0, ordinate is the 0. Then when x equal to 4, the ordinate is the 0.415, but in the compression. So we are taking compression as positive and above the line, and tension as a negative and below the line. So is above the line 0.415 and join this 0 to 0.415. Now next is when x equal to the 8, the ordinate is 0.83, means at L2 ordinate is 0.83 but tension. So we are considering tension as negative, so the below the line 0.83 and join this 0.415 to the 0.83. When x equal to 12, means when the load is on the L3, the ordinate is the 0.415 and the tension. So the tension is below the line 0.415. And finally, when x equal to the 16, ordinate is the 0. Ordinate is the 0. So join this 0.83 to the 0. And line above the line is the positive and below the line is the negative. So this is the ILD for member U1 L2. Thank you.